All right, once again, instructional objectives. Students will be able to identify the factors that affect weathering rate. Do now says, using the terms we learned about yesterday, describe how a sidewalk breaks down over time. Your vocabulary includes root action, frost wedging, acidification, exfoliation, oxidation. Try to use those terms. Today's mini lesson, we're going to talk about the rate of weathering. And our activity is physical and chemical weathering lab, which is lab number 17. Okay, so first thing you need to understand when we're talking about weathering is surface area. So the more surface area that's exposed, the quicker things break down. So in this case, we start off with an original cube, has 6 square sides. Where the square edges meet, we have these corners. And the corners are vulnerable from attack in 3 different directions, so they break down really quick. The edges here, where the 2 sides meet, also break down pretty quick. And eventually, what ends up happening is these squares turn round. Now, this one big square is pretty protected. Most of its volume is not on the outside. But if you take a look at these guys, when we split them 1, 2, 3 times, you end up getting 8 cubes. If you split them again, you end up getting 64. And all those little edges can break down. A smashed piece has the greatest surface area exposed. The interior can now be attacked. As mechanical weathering, same thing as physical weathering, breaks rocks into smaller pieces, more surface area is exposed to the chemical weathering. So this thing's cool. I don't know if you've ever seen this. This is called Devil's Tower. So Devil's Tower is a great example of how hard rock and soft rock weather at different rates. So mineral composition. Some minerals are more resistant than others. For example, quartz is resistant to chemical and physical weathering. Now, let's take a look at Devil's Tower. Long, long time ago, magma was pushed up from deep inside the earth, and there were layers of rock surrounding this area. The magma filled up, cooled, and became a very hard block. That hard block of magma eventually withstood all the weathering that erased away all that sedimentary rock. So everything got erased away except for the extremely hard igneous. Here's another example. We've got 2 gravestones. The one on the left is made of the rock marble. The one on the right is made of granite. Now, yesterday and the previous day, we've learned that marble is made of limestone, and limestone is broken down by acid rain. So you can see that the marble one definitely looks like it had a harder life. And in fact, if you read the date on there, it says 1893, where if you read the date on the other one, it's from the 1700s. The granite one looks great. The marble one, not so much. So what it's made of really tells you how quick it's going to break down. All right, guys, grab a marker. I want you to mark the specimen A, B, C, D, E, or F where the rock is the most resistant to weathering. Which layer did not break away? Was it A and C? Those guys are sandstone. B, E, those guys are limestone. D is shale. Or F is igneous. Some kind of igneous, probably granite. Only 8 out of 15 answered. Come on, I need more answers, guys. 5 seconds. 4, 3, 2, 1. Yeah, so the answer is actually F. The answer is F. Now, the reason why, and I know C kind of looks like, right? Because it's like poking out above everything. F is the highest, and it really depends on who's the highest up there, because this guy did not break down. And also, it wouldn't make sense for C to be the hardest if A also broke down as well. Which one is least resistant? That would be D. You might also see it like this on a vertical side where it's eaten away into the rock. We see this a lot on the side of waterfalls. And that brings us to today's real topic, which is climatic conditions. So, as we said, climate is the average temperature and precipitation for an area. Cold, wet climates have more physical weathering, also known as mechanical weathering. Warm and wet climates favor chemical weathering. So what we're going to do is we're going to open up our Google Classroom. We're going to click on classwork. We're going to go down to labs. We're going to open up lab number 17. Okay, you'll notice I put this cute little message here. Slide the markers up and down to identify the point of interest and also left and right. So these are your markers, so we'll be moving these guys around. I'm going to zoom in a bit so it makes it a little more clear. So you'll type your name in there. It says the type of weathering that dominates in an area depends on the climate in that area. Specifically, the major factors that control climate and thus weathering are precipitation and temperature. The graph below indicates the general relationship between precipitation, temperature, and the type and rate of weathering. So let's grab some of these markers. I'm going to take this one, I'm going to move it down. Let's look at an environment that gets very little precipitation. So if you can see here, it says average yearly precipitation. Let's put a place that gets almost no rain. And let's move this one for temperature to about here, about 5 degrees Celsius. So that's, what is that? That's like around 40 degrees Fahrenheit. What would the weather be like there? Oh, it would be obviously it'd be cold and dry. This would be like a desert, kind of like the Atacama Desert in Argentina. Very slight weathering, very little is going on. Now, if we move this up and we take a look at, let's say, I don't know, let's go to 200. 200 centimeters of rain. That's quite a bit of rain. It's almost 6 feet of rain. And we move this one to the right. We'll make it nice and toasty. Let's go for 30 degrees Celsius. It's around 90 degrees Fahrenheit. Strong chemical, meaning when rain falls on rocks, it literally starts dissolving them, especially ones like limestone. So you can see, depending on where you are on Earth, certain things are going to happen. It's either going to be mechanical weathering or chemical. Let's look at the first question. It seems like a math question. The range of temperatures on this graph is what? So we're going from negative 20 Celsius to positive 30 Celsius. What's our range? 50 degrees. Simple as that. Range of precipitation on this chart. I think you guys can do that yourself. The weathering rates are described in 4 ways. I would probably call it more like, instead of rate, I would say the weathering intensity, right? We have slight, very slight, moderate, strong. Those are your weathering rates. Let's go to the next page. Question 1. Determine the major type of weathering that occurs in Washington, D.C. if the average yearly temperature is 13 Celsius and the average yearly precipitation is 111. So 13 and 111. 111. I call that 13. So where are we? We seem to be on the border between moderate chemical with frost and moderate chemical. Well, where was the location? It said it was Washington, D.C. Excuse me. I know for a fact Washington, D.C. does get a little bit of snow every now and again. And if they're getting snow, they probably have a little bit of frost action happening. So I'm going to lean towards moderate chemical with frost. Reason why I did the first one with you is because that one kind of ended up on the line. Every other one is like within the boxes, within the areas. So let's call that moderate chemical. Uh, what was it? Frost action. So like the next one, the AYT is 9, the AYP is 98. If you do that, you'll end up right in the middle of one of these sections. And that is the lab for today. You have 9 questions, 2 of which are extended response. I look forward to reading those. The due date on this lab is Sunday by midnight. Uh, all right. If you have any additional questions for me, I'll be hanging out here. Otherwise, I will see you guys on Monday.